Under which of the following conditions is the normal approximation to the binomial distribution most appropriate? Our options are a small sample size with a small probability of success, a large sample size with an extreme probability of success, where p is close to either 0 or 1, a small sample size with a moderate probability of success, or a large sample size and a moderate probability of success. In this quiz, we'll explore the normal approximation to the binomial distribution. Specifically, we'll discuss the conditions under which this approximation is most accurate. The binomial distribution, which models the probability of a certain number of successes in a sequence of independent trials, becomes complex and time-consuming when the number of trials is large. To simplify this process, we can use the normal distribution as an approximation when the sample size is sufficiently large, which provides a simpler and more convenient way to work with probabilities in such scenarios. However, this approximation is most accurate under specific conditions. A common rule of thumb is that both the expected number of successes and the expected number of failures, that is NP and N1 minus P, should be greater than or equal to 5, where P is the probability of success. This ensures that the binomial distribution is not too skewed and has enough data points for a smooth curve to form. The probability of success, P, shouldn't be too close to 0 or 1. If P is extreme, the binomial distribution becomes very skewed, and the normal curve won't fit well. Now coming back to the quiz. A small sample size and a small p would result in a skewed distribution, not suitable for a normal approximation. A large sample size would be good, but an extreme p would lead to skewness and make the approximation inaccurate. A moderate p is good, but a small sample size wouldn't be enough for the distribution to become bell-shaped. A large sample size and moderate probability of success are the ideal conditions for the normal approximation to the binomial distribution. This confirms that option D is the correct answer.